how do we graph reciprocal inverse trig functions? So the inverse trig functions are arc, cosine, arcsine, and arctangent. We're looking at arc cosecant, arc secant, and arc cotangent. So let's start with arc secant. Well, it's closely related to arcsine. If you need to go back to the video on what arcsine looks like, it looks like this. Arc cosecant uses the same restrictions. The equilibrium point at 0, 0 turns into a horizontal asymptote at y equals 0. The points here, the endpoints, are still endpoints. And then they get closer and closer to our asymptote. So I'm going to erase arcsine, and what we're left over with in red is arc cosecant. So its domain is everything from -1 to the left and from 1 to the right. And its range is everything between -π/2 and π/2 except for 0. Arc cosecant is a descending function, and its range is between 0 and π. So arc secant is also between 0 and π, except it has an asymptote at π/2. Just like cosecant, we have an asymptote at the middle and then boundary points at the top and bottom. We can erase cosecant. Essentially, all I'm doing is using the reciprocal of arc cosine to take arc secant. For cotangent, we have to go back to our strategy that we used for sine, cosine, and tangent, which says we have to graph the original and then reflect. So our original graph looks like this, where it's descending. It has asymptotes at 0 and all multiples of π. So we can reflect that over the line y equals x. Now all horizontal pieces will become vertical pieces and vice versa. So those are our asymptotes. We can graph the reflection this way, and this repeats if we're going to look at x equals cotangent of y. But if we just look at the arc cotangent, we want to restrict it, and the easiest way to restrict it is between 0 and π. And it goes with an asymptote at π and an asymptote at 0. It passes through 0, π/2, 1, π/4, and -1, 3 π/4. So synthesizing these three ideas, arc cosecant has these two boundary points, goes to an asymptote at the x-axis, and is not defined between -1 and 1. Arc secant is very similar. It's defined with two endpoints. It has an asymptote at π/2, and it's not defined between -1 and 1. Arc cotangent has an asymptote at π and at 0, at y equals π and y equals 0, and then is a descending curve. So those are our basic cosecant, arc cosecant, arc secant, and arc cotangent curves.